All right, let's work on 3.8, implicit differentiation today. This week we cover 3 lessons. So you will have 3 homework. Well, the first 2 are very short. And many of you, not many of you, about like 9 and like 6 of you already finished homework 3.6 and 3.7. And I see that 2 people already kind of started or finished your 3A homework. So thank you. But I'm still waiting on your submission on your 3.6 problem where you show me the work on decimal approximation of square root of 19. And the Canvas quiz is still going on. I see that 30 of you are still planning on taking it. Got 3 attempts on those, on this one, and I guess unlimited attempts until Sunday night, right? So submit it early. If there's anything wrong, I will send it back. But so far, the ones that I got are looking great. So after this lesson, after these 6 examples that I will go over with you, please try this one. I'm going to ask you to find dy dx implicitly, and then find the slope of the curve at 1, 2. And the equation that I'm giving you is x cubed plus y cubed equals 9, okay? All right, so let's talk about implicit differentiation. 2 learning objectives today. We will find the derivatives using implicit differentiation, and once we find that derivative, we will find the slope of a curve at a given point simply by plugging in the x and y value. So if you got number 1, learning objective 2 is just plugging in x and y value. So first 3, I'm just gonna find the dy dx, and number 4, number 5, and number 6, I'm making the equations a little more complicated, but then we will also go and find the slope of the tangent line at the given points. Now, if you take a look, these equations are looking a little different than the ones that we were working on, right? It says 4x squared plus 9xy plus 7y squared. You notice these are not solved for y. They're not solved for y. And all these equations that we solved, or all these functions that we found the derivatives of, they were solved for y. So when do we use implicit differentiation? Well, you use this method when the equation is not solved for y explicitly. So you can use implicit differentiation to find dy dx without first solving for y. We don't have to solve for y to take the derivative of something, take a derivative of something. So we'll find dy dx implicitly today. And let's start with number 1, very similar to your first homework problem. Alrighty, so here's what we do. You take 15xy plus 2 equals 0. And what we're going to do to both sides is we're really going to take the derivative with respect to x. Okay, so take d dx of both sides. Okay, which side is easy? The right side, right? Derivative of 0 with respect to x is just going to be 0. So the right side just gave me 0. The left side, if you take a look, I have a sum of 2. Well, it's 15xy plus 2. So what I'm going to do is I'm going to separate these two. First, I will have the derivative of 15xy. And then I will add that to the derivative of 2. Okay, now just like how the derivative of 0 was just 0, constant, that's just going to give me 0. So what do I have? All I really need to find is the derivative of 15xy with respect to x, because the other guys, this is now 0, that is now 0. Okay, so this part is what we need to focus on. Now notice 15xy is a product, right? It's 15 times y. So what I'm going to do is I'm going to use the product rule. Okay, let me say that I'm using the product rule to differentiate this. Okay, because, well, the product rule, let's just write down what it is. F times g, if you take the derivative of that, that's going to be fg prime plus gf prime. Right? What's our first piece here? First piece is 15x. The derivative of f with respect to x is going to be 15. G is y. But what is, if you take the derivative of y with respect to x, what's that going to be? d dx of y, right? Just write that as dy dx. Remember that, okay? The derivative of, so note, derivative of y with respect to x is dy dx. It's not 1 because I am not taking the derivative of this y with respect to y. Because we're taking the derivative with respect to x, it's going to be dy dx. So note that, and we'll be using that pretty often, all day long, when we are doing implicit differentiation. So let's use the product rule. I need f times g. So f times g prime, f times g prime first. If I write that, that's going to be 15x times what? Dy dx. Plus, now what's next? I'm doing g times f prime. So 15 times y, that will give me 15y. And remember, the rest of them were just 0. So just set those equal to 0. Now, last thing you're going to have to do is now solve for dy dx. Because why? That's what they wanted you to find. They wanted you to find dy dx. So now we're going to solve for dy dx. All right, what do we do to both sides? Subtract that 15x from both sides so that you have 15x times dy dx equals negative 15y, right? Now, if I want dy dx by itself, I'm going to divide both sides by 15x. Then this 15x cancels out. And you know what? This 15 also cancels out too. So we found the final answer. The final answer is going to be, let me just go ahead and stick this somewhere else. And pull this over here. Dy dx equals negative y over x, right? Dy dx is negative y over x. And that's where we can stop. This is not only written in x, though, it's also written in y. So if you want to do this explicitly, solve it first for y, find the derivative of y just using the power rule. You're going to have to stick back the y there. You want to see that? Maybe later, because that's just quick algebra you can do. But that's what it is. This is the implicit differentiation. But I just thought, because it's very different from what we were doing, I want to show you more and more examples. So let's try another one on example 2, okay? So differentiate implicitly to find dy dx. So what do? We take the derivative of both sides with respect to x. So I'm doing d dx of 3x squared minus 5y squared. And I'm going to set it equal to the derivative of 3. Which we know the right side is just going to be 0. And the left side, I have to take the derivative of these two. And I'm just going to subtract them, okay? All right, you ready? Now, the first piece, this is going to be easy because it's written in terms of x. So if you take the derivative of 3x squared, that's just going to give you 6x. Now, that one was easy, right? Now, the next one, though, if you have 5y squared, and if the variable that you're differentiating with respect to is simply y, that's just going to give you 10y. But that's not it. I mean, remember the chain rule? If you had something like this, say that you had 2x plus 5 to the 7th power, and then I ask you to find dy dx. If this is y, then what did you do? You had to do 7 times 2x plus 5 to the 6th power, and then you had to multiply by the derivative of 2x plus 5, right? So you have to use a chain rule. And same thing is going on here. If you take the derivative of this term, 5y squared with respect to x, it's not just going to be 10y, okay? It's going to be 10y times derivative of y, which is what? Dy dx. and that equals 0. So when you do the implicit differentiation, again, note derivative of y with respect to x it's just dy dx. Don't forget that. You're gonna have to stick that somewhere because you realize, you're solving for dy dx, so you're gonna have to write that down somewhere. Alrighty, now we're going to solve this for dy dx, right? So once you have that, we're just solving for that dy dx. So subtract 6x from both sides. If I do that, I will get negative 10y times dy dx equals negative 6x. Now what's next? You have to just divide both sides by negative 10y, right? Then we got our final answer. Dy dx is, now let's simplify this though. Negative 6 over negative 10. Both are divisible by 2. So let me simplify this as 3x over 5y. We got the answer. That's it. And you don't have to plug in what y is to rewrite this completely in terms of x. This is where you can stop. It's just different. I know, I remember usually they're okay with all the other rules, but implicit differentiation is when things get a little bit confusing, but hopefully you're doing all right. We're going to look at a couple more together, okay? All right, another one. Ooh, super product rule is going to happen here. Suppose that x and y are related by the given equation and use implicit differentiation to determine dy dx. Now, you are good with product rule, right? I've been kind of doing this labeling, putting my pieces together, f prime, g, and g prime. But I think, it's April. You can do product rule in your head. So, you know what? I'm going to do the product rule on example 3 just in a single line without labeling everything. Because if I start labeling everything, it's going to be a lot of different things. Because notice that we're going to use product rule how many times? One time for that one and another time for that one. So I'm just going to use the product rule in a single line because I know you can handle it. But let's find dy dx by finding the derivative with respect to x on both sides. So that's what I'm doing. Taking d dx on both sides. As you know, the right side is just 0 because the right side was just a constant. Now, the left side, we're going to first find the derivative of x to the 6 times y. Plus, we're going to find the derivative of y to the 6th power times x. Okay? So I'll do these two separately. First, let me work on this one using the product rule. Okay. You see, we're using the product rule. So I'm just going to go ahead and write this down up here. Fg prime plus gf prime. That's what I'm doing. F is x to the 6th power. G is y. Okay? So f is x to the 6th power. And y g prime is dy dx. Right? Plus g. I need g now. G is simply y. And if I take the derivative of f, that's going to give me 6x to the 5th power. So I use the product rule to find the derivative of x to the 6th power times y implicitly. All right, let's go to the next guy. Maybe use a blue pen for this. I need to use the product rule again, right? Product rule. I'll say plus sign. So I need f times g. F is y to the 6th, g is x. So if you take the derivative of x, that's just going to give me 1. Plus g times, g is x, f prime. Now, f is y to the 6th power. So if you take the derivative of that with respect to x, that's going to be not only 6y to the 5th power, but what do you have to multiply to that? dy dx. Using the chain rule. And now all that equals what number? 0. Ooh, alrighty. Now, it's kind of hard to see, but we have 4 terms here. Okay, let me go ahead and circle, or at least like, so you see what I mean by 4 terms? I have 1 term. These are connected by a multiplication, right? And then I have another one. And then I have this term right here. And then the very last term over here. Now, I use different shapes, if you noticed. The ones that are circled have dy dx. I am planning on keeping those 2 circled terms on the left side, but I'll move the box terms to the other side because they don't have dy dx. I want to solve for dy dx. So, let me go ahead and write down what I have. X to the 6th power times dy dx. That first term stays there because it's got dy dx. And then the next thing that I'm going to write is that one. And that one is x times 6y to the 5th plus dy dx. And everybody else moves to the right side because they don't have dy dx. So if I move this to the other side, so by subtracting, I'll get negative y 6x to the 5th power. And then this plus y to the 6th power is now minus y to the 6th power. And I'll just get, say by times 1. Times 1 is just gone. Alrighty. Now, I just don't like the look of this guy. You see, this has y 6x to the 5th. Let me just write this a little bit nicer. How about I write that as negative 6x to the 5th y. I just switched the order of these two. And you know why it's negative? Because we had to subtract it, right? Now, why did I move all the terms to the other side if they didn't have dy dx? Because now I'm going to factor this out. Factor out the dy dx in front of it. And then write down the leftover inside. Inside, we have x to the 6th plus. Now, while we are here, let's go ahead and rewrite this in a more acceptable form. Or write the constant first, 6, and then x, and then y to the 5th. And all that equals negative 6x to the 5th, y minus y to the 6th. We are almost done, don't you agree? All we now need to do is just divide by that binomial. So divide both sides by x to the 6th plus 6xy to the 5th on both sides. And that is your dy dx. This is now canceled out. Gone. Your dy dx equals... I think your homework, though, what they did, I noticed this. Your homework factored out the negative and stuck it in front of it. Like they put the negative in front of it and then just wrote 6x to the 5th times y plus y to the 6th. And then that just getting divided by the denominator. They're the same thing, so it's okay if you don't want to factor out the negative. But I noticed that's what your homework was doing. But whoa, that one was a little bit fun, right? That was a little bit fun. So that's what it is. That's implicit differentiation with some extreme power rule product rule going on. But just take it very slow. You'll be able to get it. Let's go over example 4 now. Now, starting on example 4, I'm going to go ahead and use that dy dx to find the slope of the curve at the given point. Okay? All right. Differentiate implicitly to find dy dx. We know how to do that now. Let's do that first. So if I take dy dx of both sides, d dx of both sides, how about I'll just separate these right now instead of using up another line. I'm going to separate these difference and just take the derivative of each of them and subtract. And the derivative of 133, as you know, is just 0. All right. I like this one. Simple, right? Derivative of 8x squared with respect to x is simply 16x. But, this one is written in y. This is the guy that you're going to have to use the chain rule. So do the extended chain rule, bring down that 5 and write it as negative, bring down that 3 and write down the new coefficient of 15y squared, but don't forget to multiply this by dy dx. All right, now all you need to do is to solve for dy dx, right? So let's solve this for dy dx by moving everything to the other side. Subtract 16x from both sides. You will get negative 15y squared times dy dx equals negative 16x. Now what's next? Divide everything by negative 15y squared, right? Then we got it. Cancel, cancel. Dy dx is, it's negative over negative, so let me write down positive 16x over positive 15y squared. Circle that answer because this is one thing they wanted you to find. They wanted you to find dy dx implicitly, and that's what we did first. And then, here we go, the second part. Find the slope of the curve at the given point. And the given point here is what? Negative 4, negative 1. They're giving you, here's the x, here's the y. What do? Just plug them in. So dy dx, so the slope of the tangent line at negative 4, negative 1 is going to be 16 times negative 4 divided by 15 times negative 1 squared. What's the numerator? Is it negative 64? I think so. It's negative 64. If I'm wrong, Nicole will email me. Somebody will let me know. That's good. I love that you guys are, emailing me about the notes and problems. Thank you so much. Because I was so worried about like us all of the sudden going remote. But I'm getting feedback more than ever from you guys. So I really appreciate it. The denominator is going to be simply 15. Therefore, we found that the second answer they wanted was negative 16 over 15. So let me just go ahead and say this is the slope of the curve at negative 4, negative 1. Okay. Now, I thought that was enough, but we can do more. Just, stop the video and try the ones by yourself if you feel like, I think I got this. But, I just, I worry all the time. So I just found I got 2 more to go over with you. But that's really the idea of 3.8. This is what implicit differentiation is. But I'm going to keep on going and finish example 5 and 6. More implicit differentiation. And things are getting a little more complicated, I see. I'll find the derivative of y cubed plus derivative of x squared y to the 5th. Oh, we're going to use what rule there? Product rule. And I'll subtract the derivative of x to the 4th. And that equals the derivative of negative 11. Which we know that the last one on the right side is just 0. All right, let's go through these individually, okay? This one first. What do you think? That's going to give you 3y squared, right? Times what? Times dy dx. Don't forget, when you're doing implicit differentiation with respect to x, whenever you're taking the derivative of y term, you will get your dy dx. All right, next one. Oh, no, we have to use what rule? The product rule. So let me change the color here. Use the product rule here. And we will do this in our head, okay, without labeling everything. All right, ready? The product rule is fg prime plus gf prime. Okay, f is x squared. And I'm multiplying this by the derivative of the second term, which is 5y to the 4th times what? dy dx. All right, that took care of this. Next one, plus g is y to the 5th. And I'm multiplying this by the derivative of x squared, which is just going to be 2x. Done. That was a quick product rule. Now let's go and take the derivative of this. And we'll do minus there. Minus 4x what? Cubed. Alrighty. Ooh, it looks a little messy. But what do we have to do now? I'm going to go ahead and just go through and circle all the terms that have dy dx. That one has dy dx. And this one has dy dx. Other ones don't have dy dx. So they can go to the other side. I'm going to go ahead and send this term, these two actually. Well, I'm going to go ahead and write these as like two separate terms. This and that are going to get moved to the other side. Choo-choo. All right, look. So I will have 3y squared times dy dx plus x. Let me write this. You notice there is 5 in the middle of it. Let's bring this guy out. 5x squared y to the 4th times dy dx. And draw the equal sign because the blue underlined guys are moving to the right side. I'll write 4x cubed first, which turned into positive, and then I'll write minus 2xy to the 5th. And where did I get that from? I just switched the order of these two. Alrighty, now I'm going to factor out my dy dx in front. So that will be dy dx times, what's inside the parenthesis? 3y squared plus 5x squared y to the 4th. All that equals our good 4x cubed minus 2x to the 5th, who's just patiently waiting. All right, almost done, right? We're just going to divide everything by 3y squared plus 5x squared y to the 4th. 3y squared plus 5x squared y to the 4th. Hold on a second. So we got the answer. This cancels out, right? So we got our dy dx equals 4x cubed minus 2xy to the 5th over 3y squared plus 5x squared y to the 4th. All right, we found the derivative implicitly. It still got the letter y in it, but that's okay. We did it implicitly. Find the slope of the tangent line to the curve at the point 2, 1. So plug in 2 into x, plug in 1 into y. That's what we're going to do. So that's going to be 4 times 2 cubed minus 2 times 2 times 1 to the 5th power all over 3 times 1 squared plus 5 times 2 squared times 1 to the 4th power. All right, that will be 4 times 8 minus, now that's 1 to the 5th power over there. So that's just going to give me 1. So 2 times 2 times 1, I know that's going to be just 4. The denominator is 3 plus 20, right? Yep. All right, let's keep going. 32 minus 4 over, oh, hello, 20, not 32, 23. So what's that? 1, 2, 3, 4. I got 28 divided by 23. So we found the slope of the tangent line. Sometimes I don't trust myself with these arithmetics because I'm so silly sometimes. So give me one moment as I double check this real quick. I have my scientific calculator next to me all the time. Minus 2 times 2 times 1 to the 5th power. Okay. The numerator is 28 and the denominator is 3 plus 5 times. There's no point if I'm simplifying in my head as I type this in the calculator. So I'm going to go with it. 28 over 23 is my answer. You know what to do. If you don't get the same answer, please let me know. Alrighty, the very last one. Who's still with me, huh? Alright, we're going to differentiate this longest equation and we will find the slope of the curve at the given point. This is long, but I mean, we got this. We're going to take the derivative of the left side. And if you take the derivative of the right side, oh, you already know that's just going to be 0. Okay. I got 1, 2, 3, 4, 5 terms. You know what? I'm going to go ahead and actually do it the long way. Why not? Because I think this lesson is shorter than I expected. d dx of 4x squared plus d dx of 9xy. Oh, hello, product rule. See you later there. d dx of 7y squared. Oh, we're going to use extended chain rule there. Times d dx of 13y minus d dx of -4, of +4, because I just wrote it as a minus in front of it. Now, do you have to write all this down when you're doing? I want you to. Sometimes I'm grading your exam and you just do everything in your head and you just say, oh, positive increasing, negative decreasing. I don't want that, guys. I know you're smart, but on the exams, you gotta show me what's going on in your head because I can't read your mind. So if you can just be extreme about showing work for me, that will be really great so that I don't have to take points off. All right, let's start with this one. That's just written in x. So super easy. That's just going to be 8x. Now, the hard one now. We have to use what rule? We have to use the product rule here. Let's use the product rule. Looking at f is 9x. And g is y. So if you do f times g prime, that will be 9x times dy dx plus g times y times derivative of 9x is 9. Okay, done. Let's keep going. The next term, this one, you just have to take the derivative of 7y squared with respect to x, right? So it's not just going to be 14y, but you must multiply this by what? dy dx. Alrighty. Next one. If you take the derivative of 13y with respect to x, it's not only going to be just 13, but you must multiply this by dy dx. Okay, what about the last one? That's just 0, right? And the other side is also 0. All right, now what I'm going to do is I'm going to go ahead and circle all the terms that has a dy dx because those are the only ones who get to stay with me on the left side. There are 3 terms who had dy dx, so I'm keeping those 3 terms on the left. Can we do something cool? Can we go ahead and factor out dy dx while we are doing that? Yeah, why not? dy dx, pull it out. And inside the parenthesis, let's write down 9x plus 14y plus 13, close the parenthesis and set it equal to, and the guys who were not chosen, these were the ones that did not get chosen, they have to go to the other side. So that will be what? -8x minus 9y. Alrighty, only thing that I have to do to both sides is divide by 9x plus 14y plus 13. 9x plus 14y plus 13. So we got the dy dx now. So that's canceled out. dy dx is equal to -8x minus 9y divided by 9x plus 14y plus 13. Circle that answer for me. You found dy dx implicitly. This is lovely. Now let's plug in the x and y value. X is -1, y is 0. So if I do substitution, the slope of the curve at this point is going to be -8 times -1 minus 9 times 0. This is x, this is y. All divided by 9 times negative 1 plus 14 times 0 plus 13. Okay, what's that going to be? The numerator is 8, right? 8 over, denominator is negative 9 plus, that's 0. The next term is 13. So if I simplify that, I will get 8 over, 4. Is it really? That is super nice because that is simply 2. Alrighty, that is it. First 3 were focusing on just finding dy dx implicitly. Last 3 had just fun stuff. We just had to plug in the x and y to find the slope of the tangent line. Hope you enjoyed implicit differentiation because I know I'm going to be enjoying grading your 3.8 problem. Try that problem for me, scan it and submit it on Canvas.